Welcome to the radio frequency scientific background training video. What is radio frequency? Radio frequency is a type of electromagnetic radiation. The electromagnetic radiation, or EMR, is a form of energy exhibiting wave-like behavior. It has both electric field components, the red wave, and magnetic field components, the blue wave. The electrical and magnetic waves are perpendicular to each other and perpendicular to the direction of energy propagation. The frequency of electromagnetic waves is measured in hertz, which is 1 cycle per second. In the spectrum of RM radiation, conventionally, electromagnetic waves that range from 30 kHz to 300 GHz are called radio frequency, and those over 300 MHz are specifically called microwave. The corresponding wavelengths range from 1 mm to 1,000 km. Radio frequency is used in radio transmission, TV, mobile communications, and data navigation as in GPS or satellites. RF energy in the form of electrical currents has been used in medical treatments for over 75 years, generally for minimally invasive electrosurgeries, using homeostasis and tissue ablation, including the treatment of sleep apnea. The high efficiency of RF current for tissue heating has also made it useful for electrosurgery and an attractive source of energy for various dermatological aesthetic applications. For medical and aesthetic applications, an RF frequency of up to about 10 MHz is normally used. The distribution of electrical current depends on the geometry of the electrodes. In medicine, there are two typical RF configurations that are used: monopolar RF configuration and bipolar. In monopolar configuration, only one electrode is in touch with the skin. It is an active cylindrical electrode that carries energy to the body with a second grounded electrode or grounding pad. In monopolar configuration, a high current of RF density is generated close to the active electrode and gets weaker as distance from the electrode grows. Therefore, heat and clinical effects are limited to the proximity of the electrode to the treatment area. The ability of the monopolar configuration to create a high power density on the surface of the electrode makes it popular in electrosurgery. However, the unpredictable behavior of a unipolar system as the current passes through the body to the grounding electrode is a disadvantage in aesthetic procedures since it may cause damage to the surrounding tissue, pain, and massive necrosis. Alternatively, the bipolar configuration uses controlled radio frequency, thereby reducing the chance of any damage to surrounding tissue. In the bipolar configuration, the RF energy is generated using two electrodes. The thermal and clinical effects can safely and comfortably be sent and received from electrode to electrode at the treatment site. Bipolar energy is more localized and controlled, making it more safe and more comfortable for the patient. It has a more reliable depth of penetration and requires less energy to achieve the same heating effect than monopolar RF. In summary, the main difference between monopolar and bipolar configuration is the way in which the current is controlled and directed to the body. In the aesthetic market, there are also other types of RF configurations where more than two electrodes are integrated into the handpiece. These are commonly named multipolar RF. The well-known marketing names are tripolar, octopolar, multi-core, etc. configurations. Please note that all of these are modifications of monopolar or bipolar RF electrodes. In the multipolar RF systems, the handpiece comprises several pairs of bipolar electrodes. When RF energy is applied to the tissue, it produces electromagnetic fields. The electromagnetic field is absorbed by polar molecules and ions. This absorption causes oscillation of the molecules, which is converted into thermal energy. In other words, the rapid movement of the molecules within the tissue results in a generation of heat. This generated heat is described by Joule's law, where J is the density of electrical current and sigma is electrical conductivity, meaning the amount of heat we can produce depends on how much energy we are going to deliver, but also on the electrical conductivity of the tissue. Tissue with high blood and water content has the highest electrical conductivity, while bone has the lowest electrical conductivity with no penetration of the RF current. Dry skin also has a very low electrical conductivity, therefore we need to hydrate the skin to enhance the conductivity before the RF treatment. The conductivity is measured as a ratio of current across the voltage. The opposite of conductivity is called resistance or impedance, meaning how much the skin is resisting the electrical current. The RF energy penetration depth is influenced by four main factors. The RF energy fluence, where the higher the fluence, the deeper the penetration. By the skin's electrical conductivity, where the higher conductivity, the deeper the penetration. By the RF frequency used. And finally, the distance between two electrodes. The last two we will discuss in detail. Any energy that has wave-like behavior, including RF, light energy, lasers, IPL, ultrasound, etc., the frequency of a wave is always inversely proportional to the wavelength. As you can see in this equation, the frequency of the wave is phase velocity divided by the wavelength. Therefore, longer wavelengths always have a lower frequency, and short wavelengths are in high frequency. In addition, according to the physical behavior of the wave, longer wavelengths penetrate deeper into the skin, while shorter wavelengths penetrate more superficially. The short wave interaction with the tissue creates high resistance, which prevents its propagation deep into the skin, while longer waves create lower resistance and are able to penetrate much deeper. As frequency is inversely proportional to the wavelength, it means that low frequency penetrates deeper in the skin and high frequency waves penetrate superficially. This is much more clear in the RF energy penetration depth equation, where the standard depth of penetration in millimeter is equal to 1 divided by the square root of pi, frequency, magnetic permeability of the tissue, and sigma, tissue's electrical conductivity, meaning that the penetration depth is inversely proportional to the frequency, and lower frequencies have higher penetration, and vice versa. The last parameter is the electrode size and the distance between electrodes. In monopolar configuration, the theoretical maximum depth of penetration is half the size of the active electrode. For example, if the electrode length is 10 centimeters, the theoretical depth is approximately 5 centimeters. In bipolar configuration, the distance between the electrodes will influence the depth of penetration. Here, half the distance between the two electrodes is the theoretical maximum depth. For example, if the distance between two electrodes is 4 centimeters, the theoretical depth is approximately 2 centimeters. The last very important issue related to RF technology is the safety aspect. Many patients and sometimes practitioners have concerns regarding EM radiation exposure and how much is safe to be exposed to the RF energy. First, let's have a look again at the EM radiation spectrum. In general, we can divide the entire spectrum into non-ionizing radiation and ionizing radiation. The ionizing radiation is radiation that carries enough energy that can produce ionization of atoms or molecules. In other words, it's a process in which an atom or a molecule acquires a negative or positive charge, an ion, by gaining or losing electrons. This can lead to radiolysis or breaking chemical bonds and formation of highly reactive free radicals. The medical and aesthetic RF systems are located in the non-ionizing radiation spectrum. Moreover, the RF systems are located to the left from TV or our mobile phones, making the RF technology safer than our home use devices. RF energy is non-ionizing energy. Thank you for watching the radio frequency scientific background training video, and be sure to follow up with Vior's clinical team if you have any questions.